So now 2 weeks have passed, so therefore from now onwards we expect that there should be complete regularity in attendance of all the students. Additional means the classroom recording should be taken as supplementary to actual lecture and not its substitute. We will be trying our level best to ensure that each and every individual gets a thorough insight of microprocessor. And we are experimenting in a novel way. The material was already put, you might have gone through. Some additional material I will put. We will create a Google Classroom in which assignments will be there. You have to read the material and put something in your own handwriting and so forth. We will have a complete departure from classical approach wherein the understanding index is very less. So we try to focus on more understanding. So somehow in the last lecture when we shifted, that part was not recorded, anyway it has gone. But we will have a recap and we will continue further. So what is a microprocess means now? As regards to our lectures are concerned, everybody should be able to connect to it from the, what we can say, bottom of not his heart but his intellect. That each and every sentence I utter from here must be understood by everybody. Attendance sheets. If ever there is some impediment in understanding, we will focus that. We will focus in the classroom if needed, we will focus in revision session if required. So, what microprocessor is, that we have concluded that microprocessor is a non-living servant, right? So I try to make it more clear so that there should not be any gap. As already stated, we need to meet at strong Thursday and Friday morning 9 a.m. So we said, because we should fulfill the purpose for which we are here. So understanding is important. Non-living servant. Microprocessor is a non-living servant. Then master servant. Servant is supposed to carry out some task. Servant is supposed to carry out some task. So what task microprocessor can carry out? That also means when you appoint a servant, you check his skill set, what he can do. Like that, what microprocessor can do? What is microprocessor? Again, I repeat, von Neumann model of 885. That is, it is having externally 16 address lines A15 to A0. Those who are extra sincere and curious students from your class, there might be few. They might find that the literature which they come across on their own, out of their own curiosity, and the discussion in the classroom, they may find that there are some differences. But let it be clarified once again and once and for all that these differences are deliberately introduced by me so as to simplify the understanding. So if ever you find that reading of additional material is confusing, then stop reading that and listen, provided that you are listening this carefully.
Can you use the mic?
Mic is needed?
Yes.
So, if you find that the discussion which we have here and that which is in other material, there is some discrepancy, that discrepancy is whatever you read elsewhere is a fact. Whatever I introduce here is deliberately twisted fact with an intention of understanding. So 16 address lines A15 to A0. These are output lines of microprocessor. CPU, microprocessor, computer. These terms are used interchangeably in different contexts. Therefore, for our purpose now, what we do is, we say that we don't go into those confusions. We directly say that this is 8085 chip, as simplified by me, right? So we now focus directly on 8085 chip. 8085 chip is an integrated chip, which is a digital chip which contains a very complex digital circuit, obviously comprising of multiple gates. Entire digital circuit cannot be discussed here because that will require you to abandon studies of all subjects and continuously go through these sessions only. That is not permissible. But however, whatever is needed, that we will go through. So it is having 16 output lines. Output lines means microprocessor will make it 1 or 0. Is it clear? It is output line of a digital circuit. It is 8085 which can make each and every out of these 16 lines 0 or 1. So there are 16 zeros to 16 ones. What is hexadecimal? Let it be clarified again once and for all that hexadecimal is not a separate number system. Do you agree or not? Then what it is? Representation of binary. Where you read this? Huh? In videos. Binary number system, hexadecimal number system is not an independent number system at all. It is just compact representation of binary by taking 4 bits together and representing it by a separate symbol which is having 16 combinations from 0 to 9 and A to F. Agreed? So what are 16-bit combinations possible? All zeros, 16 zeros to all ones that we represent by, and now to have a difference between binary 0 and hexa, it's not a difference actually, but we should understand what it is. So there is a convention that is not so critical, but the convention is there that we write in 0, 0, 0, 0. We just something like 5, and that is H. We write H. 0, 0, 0, 0, H to F, 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 H. Right? So, with the help of address lines, why it will do, what is its use. Suppose I can do many things, I can do some things for nonsense purpose also. Right? So, like that now, right now what we are talking about, what microprocessor can do means I can do something by I am having some organs, say hand is an organ which means whether using eyes is an organ, using eyes you can do something, that observing someone with anger like that, but that is exceptional. Otherwise from using eyes you can read something and not write or not output anything, right? Hand is output organ so that you can do something like that. Address lines are output lines of microprocessor. So microprocessor can, so what are the possibilities which a microprocessor can do? There are 2 raised to 16 possibilities because there are 16 address lines. Is it right? So 0, 0, 0, 0 hex to F, 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 F hex, or if it is in decimal, 65,535. 0 to 65535. So 6, that is called as 2 raised to 10 is called as 1K. 2 raised to 10 is called as 1K, some kind of short form, kilobytes, right? So 1, because each representation, that will come to letter, each representation 1 byte. So microprocessor can output any of total 64K combinations on address output lines. Is it right? This is what it can do. Then microprocessor is having 8 data lines. Microprocessor is having 8 data lines, but data lines are bidirectional in nature. Listen very carefully. I am explaining the entire microprocessor architecture in the simple, most possible way, to such an extent that simpler than this is nowhere available. So data lines are bidirectional, means microprocess means, suppose that a teacher is engaging viva of a student. So teacher will ask the question and student will answer the question. So the data flow, if we talk of data flow is bidirectional. So it is microprocess, means now microprocessor is connect, as Von Neumann has said, that there are data lines. So 8085 has got 8 data lines. I again repeat that multiplexing of address data is not required for this understanding, so I have skipped and made it simple. So there are number as D7 to D0. These are number as D7 to D0. And microprocessor can either use address and data lines for writing something somewhere or reading from somewhere. I listen the difference. Writing something somewhere, and I have said reading from somewhere. I am not using the word something here. Why? Because in write cycle, it is microprocessor, it has to supply a 16-bit address and also it has to supply 8 bits of data. So in a write cycle, microprocessor outputs any 16-bit combination on unidirectional, that is output type address lines. Then microprocessor outputs 8-bit combination on 8 data lines which are bidirectional. Now outputting on unidirectional lines is okay because these are output lines. But when I output something on bidirectional lines, what care must be taken? These are bidirectional lines. You got a question? It's common sense question. Whenever I ask the question in the classroom, either the questions are pertaining to the contents which we have discussed earlier, or these are common sense questions. Anyone? Now, what risk, what threat is involved in outputting on bidirectional line? It is bidirectional. So microprocessor is actually connected. Microprocessor's output line 16, its bidirectional lines 8 data, and there are 2 more lines which indicate what operation which it intends to carry out. And who decides which operations to be carried out? Microprocessor. Whether to read or whether to write, therefore both lines are output lines. Is it clear? Both read and write, to be very precise, the read bar and write bar, active low logic. Why active low or why active high? Say in India we are having the right hand, or if you travel through left lane, whereas in US you may travel through right lane. Why left or why right? It is not that this is better or this is otherwise better. So some convention like that, there is a convention of active low or active high. So in many times in digital logic, active low is considered to be a well-established convention. It has got its few advantages, but that is not our botheration right now. So for 8085, it is active low. So the control line which is activated for reading is called as read bar. Right? Is it clear? Read bar. Bar indicates it's active low. Means whenever microprocessor wants to read a memory location, it will make it low. And when high, it is not active. Is it clear? Similarly, there is another output line called as write bar. Is it clear? So externally microprocessor is having 16 plus 8 plus 2, that is 16, 8 and 2. How many pins are there? 26 pins are there. 80 divided by these 26 pins. Additionally, it is having 2 more functional pins. What those are? One is a clock. Just means, I think that now you are so advanced that it is just like hard, such example need not be given. Clock is an input pin to microprocessor. 8085 used, nowadays we are in the world of gigahertz, but 8085 used to operate on 3 megahertz clock. So, why clock is needed? Why you need a clock? To sequence your activities, to schedule your activities. Like that, the microprocessor activities are scheduled based on clock cycle. One clock is input, so who gives out, clock is input terminal to 8085. So it is coming from some clock generator. Some clock generator will provide a 3 megahertz clock. This is 3 megahertz clock generator. So, and if you see, deliberately it is shown somewhat slanted. It is not. That slanting indicates that the speed is very high. So, as speed is very high, suppose clock is in kilohertz, then the time from 0 to 1 or vice versa, even though we expect it to happen instantly, it takes some time. So when it is in kilohertz, it takes some time, then for some milliseconds it is constant. Then again it changes. But when it is in megahertz, the time for which it is constant is also very low. So the time for switchover cannot be ignored just like a vertical edge. Is it clear? The high frequency clocks are drawn trapezoidal in the diagram just to indicate that the clock change over time is not completely negligible to the time for which clock is at one level 0 or 1. Is it clear? Other than that, there is no significance. So, from one, and again there is logic. Why? Don't know. When it need not be probed also. Clock cycle begins, means clock. It begins from high to low transition to next high to low transition. So this is, in a standard way we say this is one clock cycle, but it is not so. This is one clock cycle. This is one clock cycle. So one clock cycle corresponds to the time from one falling edge of the clock to next falling edge of the clock. Right? One clock cycle. And such 3 clock cycles correspond to one machine cycle. Such 3 clock cycles correspond to one machine cycle. Machine cycle is very significant entity in the entire operation of 8085. Is it clear? Then one more pin is needed. Now why it is needed? For that I differ for some time. I draw next part connected to microprocessor, and so one pin is input pin. I will name it, I will create an environment so that you will be able to name it on your own. So these are 26 to 28 and 2 more pins which are must. What are those? Which I have not shown. for every digital chip, the 2 pins, which, what are those?
Resetting.
Which one?
Resetting.
No. That is not. 2 more, I said.
This one has
For every, it may be gate, VCC and ground, supply pins. It must not supply, right? So 2 supply pins, these are assumed. So you will find that in the various diagrams, you don't show because those are assumed to be there. Means when you come to Walchand College, every time you don't enter Walchand College. Right? Because it is assumed now. It is embodied in you. So like that 2 supply, to be very precise then and detailed, 2 supply pin. So 16 address, 8 data, 2 control, 1 clock, 1 more and 2 supply pins. So it's a 30 pin IC. It's 8085 is a 30 pin IC. Only thing is that don't tell it outside the world. Because they will show some, your teacher might be not knowing few pins, so you skip the pins. That may say in that context. So but for our understanding, the 30 pin 8085 model is the best model through which it can be learned. Means if ever it can be understood, or its contrast, if it cannot be understood by this model, then no other model exists in the world which will make its understanding further simple. Right? So 30 pin IC. So supply pins, let us forget forever in the sense that these are always there. Now this is the 8085 chip. Now it is connected to exactly complementary device. What that device? We will come to know slowly. So this is 8085 microprocessor. It is connected to another device. Obviously again it has supply pins. We don't show it again, right? It is connected to another device which is its exact complementary. Now its details, exact circuit details are not needed. Block details. Means in the sense that we must not assume everything. At the same time, its contrast is not also true in its entire context. We cannot probe and question everything. If we do so, we will be going into endless trap that we don't want to avoid. But we must be able to find. I hope that even though the speed is somewhat less, speed is somewhat more, the wording is appropriate. So there should not be any problem in understanding. If it is there, then there is solution. What is the solution? "30 years back in India, at 2 p.m. in the afternoon, All India Radio was to telecast English news, 2 to 2:10. At 2:10 to 2:20 Hindi news, and at 2:20 to 2:40 it was slow speed English bulletin. Whatever was uttered from 2 to 2:10, same thing was uttered at half the speed from 2:20 to 2:40. So now what you are supposed to do when it is on YouTube, you know if there are very slow contents and you are what do? You run it at 1.5x so as to quickly finish it. If you find that this is fast, then you can run it slowly. So that anyway. That recording is continued and my talk is also continued, but I again forgot anyway. I should have brought it disturbed, but still let us hope that the supply will come before I need actually the diagram. I hope that this will give us sometimes difficulties create new opportunities. So you just imagine how a blind person is learning. Are you getting me? How a blind person must be learning. A blind person learns on a mental plane. He is unable to see the actual board as such, but he is able to visualize that on his mental plane. So you can experience it now. So microprocessor outputs, address lines, data lines and control lines. Then the 2 cycles are defined. One is a read cycle and another is a write cycle. Each of them is a 3 clock cycle machine cycle. Read cycle or write cycle. In the first clock, means before micro decides what the cycle it is going to have, so it activates. If it is read cycle, what it will do? It will decide what. Okay, so I hope that there is no need of board. We can interact and you will be able to answer. For a read cycle, before beginning a read cycle, what microprocessor needs to decide? Suppose that tomorrow you say that I will start studying. Then what you need to decide? Okay, not how to study. Let us say that studying has got two parts. Number one, reading. Let us say reading. Then what do you need to decide? You intake. Now you say that my college is over. I have just finished some other things, and now in this 1 hour slot, I am going to read. So before proceeding to read, what is needed to be decided? The location from where to read. Is it right? It is enough. But instead of that, now say some assignment is given for many subjects. Then you find that I also need to complete assignment. So you decide that now I will complete assignment, writing of assignments. Then what you need to know? What you need to decide? Where to write that assignment notebook, and but for a read cycle, for reading operation, a decision on from where to read is enough. So during the operation, you decide the location or called as address from where to read, and the contents are the moment at which you open that book, the contents are in front of you, right? So contents means microprocessor, what it does in the read cycle, in the first clock cycle of the read machine cycle, what it does, it activates appropriate address on address lines. So just like page number, there is location number, location address. So how many locations are there? 2 raised to 16. And each location is of how many bits? 8 bits. So that can be all zeros to all ones. So before beginning of a read cycle, microprocessor decides the location. Decides means what? Some 16-bit value should be provided, that it decides and provides on the address lines in the T1 of the read machine cycle. Then that address gets settled down. Then microprocessor makes read bar low, means or microprocessor activates read bar. Microprocessor makes read bar low and keeps it low for entire T2 and keeps it low for entire T2. So when it keeps it low for entire T2, that time what must happen? For the circuit which we have shown to be connected to microprocessor and which is exactly complementary, what that circuit should do? In that means you open the page. When you open the page, contents are in front of your window. So like that, that circuit is a memory circuit. That is a memory circuit. So memory is having 26 external pins which are exactly complementary to microprocessor. So 16 address lines which are output address lines from microprocessor are now input address lines to memory. Read bar and write bar, which are also output lines of microprocessor, are input lines to memory, right? And data lines of microprocessor, which are bidirectional. What is complement of bidirectional? bidirectional only. So those are also bidirectional. Then when microprocessor outputs an address and makes the read bar low, what memory will do? At every location something is stored. There are 65,536 locations. At each location what is stored? Some 8-bit value starting from all zeros to all one, that is 00 hex to FF hex. So that value means that microprocessor outputs address lines, so that location is selected, and when read bar is activated, the data in that location is actually put. So bidirectional lines are very interesting. I am not sure whether you have listened the video of tri-state buffer in my videos, lecture videos. So tri-state buffer is very important. The bidirectional line, bidirection is not so easy. What is the risk in that? If both output on the same line, and one tries to output 0 and one tries to output 1, there will be short circuit. So bidirection, there is a tri-state buffer. Bidirectional lines are hanging lines. So nobody puts anything unless other asks that device to do. So when the read bar is activated, then the memory puts the data on those data lines. So that is available to microprocessor on data lines, right? So when you open the page, whatever is on the book that is available to you, what you do that? With that, you read. Means, now, human being and machine, there are many differences. Suppose that some teacher is highly disciplined, much more than me, then he forces you to go into study room. And now let us have common reading. Samohik Vachan. Open the book. Then the Kanya in front of you. But what you may do? You may pretend to read. Actual reading is not that everything you are storing and summarizing, but for machine it's simple. So what machine should do? Somebody said something. I think in my videos it is there, but if she has answered without video, then it is really appreciable. If it is answered while watching videos, still is appreciable. And if it is not answered by anybody, it is not non-appreciable. So what microprocessor should do now? What microprocessor has done? Microprocessor has activated some address, put address on address lines, activated read bar, right? That memory will put something on data lines. What microprocessor should do with it? Means what? Reading means, see that human beings, natural actions, we are so used to it that we can describe. म्हणजे आपण ज्या बऱ्याच गोष्टी करतो त्या आपल्या इतक्या अंगवळणी पडल्या असतात की आपण त्या करतो म्हणजे नेमकं काय करतो हे लिहू न शकत नाही. इज इट क्लियर? सो मायक्रोप्रोसेसर शुड डू exactly what with that? Store the contents. Temporary, we need not jump to temporary right now. So then prior to that, one next question. Address comes on address lines. I said microprocessor wants to undergo a read cycle. So for a read cycle, address must come from microprocessor. So microprocessor should give address. Means, listen very carefully, this you might have seen in the videos. If not and still you are able to answer, it is very nice. But is it very nice? In two ways. Just like say that there is a security guard in a palace. The security guard gets a dream that there would be murder of the king if he goes somewhere. The next morning he tells the king that I got this thing in my dream. Then what the king does? King awards him handsomely and terminates him from duty. awards him for saving his life and terminates from duty because as he was dreaming, he was supposed to guard in the night and he was sleeping. So now if you answer the question without watching the videos, then on one hand it is very extraordinary, but at the same time it indicates you have not watched the videos which you are supposed to. So in a read cycle, microprocessor gives address. So microprocessor gives means what? It must come from where? Can you give the answer? Microprocessor giving address is not so simple. Now the lecture is over and there is a break. Not this, after this, say at 3:15 lecture. Then from here you go to some place which comes in your mind. Means you go where you want. But exactly the location which you reach, how it is decided? That must be that must be stored somewhere. For us everything is integrated, so we don't know its ingredients. But for microprocessor now, can you clarify further? For a read cycle, microprocessor should give address. But microprocessor is not you. माझ्या मनात आलं असं आपण म्हणतो. That luxury, that frame is not there for microprocessor. So, what should happen?
use it from the memory.
External memory, how external? Not necessarily. The address for a read cycle must come, it comes, microprocessor gives that. Means suppose if you donate, you say, and so you say that I am very generous donor like Karan. But when you say I donate, you must have received it from somewhere. It should come to you from somewhere. Right? So like that when I say, microprocessor gives 60-bit address. So that is incomplete statement. So it means in a read cycle begins means what? Address appears on physical address lines of microprocessor, which are output lines. But it can't appear from vacuum. Then from where it can come there? From more further means inside microprocessor what you have said, what we have?
Register.
Last time we had said that there are one register of 8-bit. Accumulator, B register, C register, D, E, H, L, and program counter, higher program counter, though a program counter is 16-bit register, stack pointer, higher stack pointer, though stack pointer is a 16-bit register, register pair rather, and W and Z. So we should be very clear in mentioning that. I hope that most of you have come to this answer but not able to find exact wording to describe, and once you listen from me, it's a very important point. Say that when you are listening and you are listening carefully, is it that you are able to predict every sentence which should occur next? That is possible only if you are watching a replay. If you are watching something which you have not listened earlier, then you can't predict what exactly will be next sentence. But is it that every next sentence is no way connected to earlier sentence or the current context, then it should be talk by absurd talk by mad fellow. Is it right? If you are not able to exactly predict the next sentence, if you are able to predict the next sentence, then there is no need for you to listen. It is completely memorized by you. If you are not able to predict anything and the next sentence is totally random and arbitrary, it's a nonsense and absurd talk by mad person. If it is neither of these two, neither entirely predictable like a recorded session, nor completely unpredictable like an absurd talk, what you must be able to do? You must be able to anticipate the next sentence, not exactly, but next sentence would be something from these 4, 5. And then you listen that. That is called as, when you are attentive in a meaningful listening, then this happens. So, I suppose that most of you are predicting to some extent what I am saying now. That is, for a read cycle, one of the register pairs should give address. Why register pair? Because one register is 8-bit. So, BC pair, DE pair, HL pair. Program counter is in a way pair, but we don't call it a pair because PC is 16-bit register. It's individual H and L, we say separate ones, right? So one of the 16-bit registers or a register pair must give the address. Right? Is it clear? So for every read cycle, address must come from some register pair, right? And data is available. Where that should go? That should go. Don't try to think much more to be so specific. Exactly reverse of this. So where data should go? One of the registers. Is it clear? So a read cycle of microprocessor must have one source register pair which will specify the address which should go on address lines, and one destination register. The data must come to that register. Is it clear? It is for read cycle. And for write cycle, what we should have? For write cycle, what we should have? For write cycle, it is the microprocessor which gives address as well as data. So what we must have? We must have one register pair to act as address and one register to act as data, both sources. So read cycle, a register pair as source and register as destination. For write cycle, a register pair as source and a register as another source. Is it clear? So what it will do? It will output address on address lines, data on data lines, and make write bar low. Then what memory is expected to? Memory is expected to store that value in that location. Is expected to. It may or may not. Just like I say take down. When I say take down, you are expected to note down, which you may or may not. So microprocessor means there is no way by which microprocessor can understand whether its instructions are being followed by the memory or not. Means microprocessor is completely ignorant about even the existence of the memory. Now what microprocessor is? I am the king. What I will do? I will put address on address lines. Now, a very interesting thing. What should be the first cycle after reset? So I somehow use the term reset, which actually I want to differ. There is one more pin as input pin called as reset. Here set a reset, which is again active low input pin, reset bar, or called as reset in bar. When that becomes low, microprocessor prepares to start, not start. When reset in bar is made low, microprocessor prepares to start, and when it is made from, when it is when reset in bar is activated, microprocessor prepares to start from the beginning. And when it is deactivated, when reset in bar becomes low to 1, low to high or 0 to 1, microprocessor starts functioning from the beginning. Then externally what microprocessor can do? Microprocessor can have a read cycle or a write cycle. Then you tell me, after reset, what should be the first cycle? Read or write? Read. Now, you assume, now read we say, but suppose that if the question is asked in a public discussion, then he will say, why not write cycle? Are you getting me? Then you have to prove that write cycle cannot be there. How to prove? Assume that there is write cycle. Are you getting me? That is proving by negation. Assume that there is write cycle and proceed further and end up in such a situation which is an impossible situation or meaningless situation like that. So let us assume, for read cycle what is needed? For read cycle what is needed? One register pair to act as address source. That's all. So after reset, just like in last lecture I said that a very hi-fi student who has copied something, he knows the question paper, answers in different pockets, but he's so dumb that he can't remember that even. So they cheat stating which question in which pocket, that cheat in the front pocket, and he has to at least remember that. I have the master cheat in front pocket. If that, and that can be written somewhere, that must be hardwired in him. So like that, after reset, what should be the first cycle? That should be hardwired. After reset, there should be a read cycle for which register pair. So that also must be predefined. Means after reset, the first cycle will be a read cycle for which this source register will, this register pair will act as a source. Then we say, no, why you should think? Because you are now thinking, because you are thinking in one direction. You can extend, there can be write cycle. So what is needed? One register pair and another register. So it's okay, no problem. That can also be hardwired. What next? So let us say that after reset, the first machine cycle is a write cycle for which stack pointer will give the address and register B will give the data. Let us say. Okay, then what? So let it be. So that first cycle is over. Then what the next cycle is? That microprocessor is like that dumb fellow. He can only remember first cycle. Next cycle he can't do on his own. So what? So if first cycle is write cycle, then what next cycle is? After the write cycle, no change has taken place in the state of the microprocessor, so that the same question, what next cycle should be, still pertains. Whereas, if the first cycle is a read cycle, then microprocessor gets something. So what next may depend upon that. Therefore, first cycle must be a read cycle. We can do next time.